Welcome back. In the last video, we defined the Riemann sum and the definite integral. In this video, we want to understand exactly what we're computing when we're computing these definite integrals. So let's talk about area and net area. So assume that y equals f of x is a positive function, so something like this curve, and let R be the region bounded by the curve y equals f of x, y equals 0, x equals a, and x equals b. So this region right here would be R. A Riemann sum, Sn for f of x over ab, computes an approximation for the area A of R using n rectangles. Like we said before, as n goes to infinity, this approximation gets closer and closer to the actual area. Hence, the limit of the Sn as n goes to infinity, which we call the definite integral, gives the exact area of R. So let's put that inside a proposition. Proposition 4.1.3. Let f of x be a positive function on AB, then the area A of the region R, bounded by the curves y equals f of x, y equals 0, x equals a, and x equals b. So this region right here is actually the integral from a to b of f of x dx. All right, so we're computing the exact area if we can make sense of this, and of course, this formula, right? All right, so here let's put -1. That's what I meant. Example 4.1.7 computes the integral from -1 to 1 of square root of 1 minus x squared dx by expressing it as an area. All right, so we have the function y equals square root of 1 minus x squared. So if I square this, I'll get 1 minus x squared, which means that I really get x squared plus y squared equals 1. Right? So what I'm getting, if you remember this, we saw it earlier, that's the circle. So y equals f of x is part of the circle of radius 1. Which part? Well, I chose the positive root, so it's the part with y bigger or equal to 0. Right? So if I sketch my region, my function is going to go from -1 to 1. Those are the bounds we picked. And all right, so if we look at the proposition, we're going to get the region bounded by the curve y equals f of x. So that's the one I drew in black. Y equals 0. Let me put that one in purple. From x equals -1 to x equals 1. So the region whose area corresponds to this integral is this region right here. So the integral from -1 to 1 of square root of 1 minus x squared dx is the area of R, which is, well, it's half a disk, so it's half the area of the disk of radius 1. And so that's half of pi r squared, so it's pi on 2. All right, so in most cases, we'll use the integral to evaluate the area, but since we're not good yet at evaluating integrals, in this case, we actually knew the area from work that we've done in high school, and so we were able to say that that was pi on 2.